go ahead now and take a look at part 3, all right? So here's another type of question that you can ask dealing in your elasticity chapter. So what we have here is a company has determined that the demand for a product is given by P is equal to the square root of 25 minus 2.5x. What price will maximize the revenue? We know that we will maximize the revenue whenever E is equal to 1. So what we need to do is we're going to find my elasticity function, set it equal to 1, and then solve for P. Okay? Now, your elasticity function, as a reminder, is negative P times F prime of P over F of P. And remember, F of P is equal to X. X is equal to some function of P. I don't have that. Right now what I have is P is a function of X. So what you need to do before you even begin, you got to do algebra to solve for that X, and that's going to be your function of P. So, bringing this over here, if P is equal to the square root of 25 minus 2.5x, let's go ahead and do a little bit of algebra to solve for x. So I'm going to square both sides. I get that P squared is equal to 25 minus 2.5x. Then I'm going to add the 2.5x over to the left side, and then I'm going to subtract the P squared and put it over on the right side. So what we're going to have is 2.5x is equal to 25 minus P squared. And now to solve for x, you just divide by 2.5. And so I have that x, which by the way is your F of P, is equal to, well, 25 divided by 2.5 is 10 minus 1 over 2.5 P squared. And if you wanted to write 1 over 2.5, I know sometimes people get freaked out with fractions and decimals. You just put in your calculator 1 divided by 2.5, and this would be just 0.4. Okay, so if it makes you feel a little more comfortable, you can always just write this as 0.4. You have a calculator, take advantage of it. Alright, so now that I have my F of P, now let's find my elasticity function. And so my E is going to equal negative P times the derivative. So the derivative F prime of P is negative 0.8P. So this is going to be times negative 0.8P divided by F of P, and my F of P is 10 minus 0.4P squared. And what I want to do is I want to set this equal to 1 and solve for P. Let's just simplify it a little bit more, that way we make our lives easier. This negative P times a negative 0.8P, this is going to be positive 0.8P squared divided by 10 minus 0.4P squared, and I'm going to set it equal to 1 because this is when my revenue is maximized. Your revenue is maximized when your elasticity equals 1. Now how am I going to do this? Well, the way you're going to do this is, notice I have a fraction is equal to 1. I don't want a fraction, okay? That makes it really complicated. So what we're going to do is we're going to multiply each side by 10 minus 0.4P squared. I'm going to multiply each side by 10 minus 0.4P squared. That way, these guys will cancel, and what I'll have is 0.8P squared is equal to 10 minus 0.4P squared. I'm going to take this 0.4P squared, add it over to the left side. So we got 1.2P squared is equal to 10. I'm going to divide 1.2 to each side. So 10 divided by 1.2, we get 8.33. So P squared is 8.33. And then finally, to solve for P, you would take the square root of each side. So taking the square root of 8.33, I end up getting about that P needs to be 2.89. And so given that this is my price function for this certain product, your revenue will be maximized whenever you set it to a price of $2.89.